I hope all of you are having a wonderful time here at the AI show. At least I am having a lot of new things to learn. Impressed by seeing how AI is transforming, especially in this part of the world as well. So what I'm going to do today is, obviously on the topic, you see a few jargons and buzzwords that all of you would have heard, right? We speak about digital transformation, digital world, customer experience, data science, AI, how is it changing all of that? Right, so we'll touch upon a few of those jargons, how we are trying to address that, our point of view towards that, and how we have solved these problems for some of the global clients as well. So let's start by looking at customer engagement or customer experience itself, right? Probably 25 years back when I was still in school, the only way of transaction my parents did was go to a offline store, pick up things, pay the money and get it, right? That was the only form of transaction that used to happen. Then we said, let's put everything on the website because we now have this wonderful thing called as e-commerce, right? Why not sell things online? Let's do that. Then we said, okay, we'll talk to customers on the phone. Let's pick up a phone, talk to them, understand their pain points. Then we said, let's build chatbots, right? That's a good way of interacting with customers. And now we are really going crazy. We have invented this beautiful concept called as Internet of Things. Obviously, the latest one being metaverse, virtual reality, artificial reality as well, right? So what does that mean in terms of customer engagement, right? With the change in customer engagement, the data that we are generating as well is changing, right? Historically, all that we used to have was ERP systems. Then we started having clickstream data, which is the website data. What are users viewing? Where are they clicking? Each click was being tracked, right? Audio calls, chat transcripts, text, images, videos, and now we are talking about augmented simulations as well. What does that mean? If you look at the entire spectrum of data, the intelligence of that data is continuously increasing. The amount of gold mine of information that you can have from these forms of data is tremendous, right? Because you are not just looking at a table and a column, but you are actually understanding what the customer is trying to do, or what the customer is trying to speak to you or trying to express himself. But with that intelligence or the richness of that data comes the complexity to decode that as well, right? Historical data, ERP systems, relational databases, very simple to understand. But how do you decode textual data? How do you decode images? How do you decode videos? How do you now decode augmented reality, augmented simulations, right? Understanding all of that, doing analytics on top of that became very, very challenging, obviously. So we were then faced with a few hurdles. What were these hurdles, right? Big data became really big. 10 years back, the definition of big data, as you know, was probably metabytes, petabytes, terabytes, right? I don't even know if we have a term for the size of data that we have today now. Velocity changed. We are talking about real-time data, streaming data, and whatnot. Second, so when we started solving these problems one by one, right? With big data, we figured out, yeah, parallel processing, high-performance computing can solve that. Decoding complex data, we came up with things like natural language processing, computer vision, and so on. Efficiency, now we have tons of pre-trained models. Amazons of the world, IBM Watsons of the world, Googles of the world are building those models as well. And finally, we said on the consumption, we will enable things like no code, right? Even a non-technical person can come and build a machine learning model today if you have the right platforms in place. So then now it seems all in place. Magic should happen. AI is in place. We have solved all the hurdles, right? Put in the data, and we should get wonders out of AI, right? Probably not the case. These are just few examples of some of the big players still making it wrong, right? This was a self-driving car test that Uber did, and Uber themselves accepted that it made 6 violations of a red light traffic. OpenAI GPT-3, probably the biggest thing that happened in the NLP world last couple of years. A French bot suggested someone to go ahead and do suicide because the NLP model was trained wrong. Indigo Airlines from India, horrible mistake on sentiment analysis. A customer actually made a sarcastic comment. The algorithm said, glad to hear that, where the customer is actually complaining about his lost baggage. Right? So what does that mean? We have figured out so many things. We have made so many transformations in AI. We have solved all those hurdles that we talked about, right? But why are still things going wrong? So that's where we want to present our point of view, having done this numerous times for our global clients. Across industries, we feel there are certain guiding principles that you really need to think about while building any AI solution for that matter. One, obviously define the use case. Time and again, I hear my clients say, hey, we want to do AI. We want to do AI in marketing. We want to do AI in finance. We want to do AI in banking. My question is, what's the problem that you're trying to solve, right? What's the objective that you're trying to achieve? Are you trying to get more customers? Are you trying to give them a better experience? Are you trying to drive margins, revenue, and whatnot? All problems, all AI solutions should start there. Define the use case. Just looking at models, accuracy is not the end game. Once you have defined the use case, where does the data come from? It's a known fact that machine learning, AI, it's a garbage in, garbage out concept, right? You feed it garbage data, it will throw out garbage outputs. What we mean by ensemble approach, which is the third principle, is that we have never found an instance where one solution made the cut, right? There is no single silver bullet. You have to try and try again, and that's the fourth principle as well, what we call as extreme experimentation. The more number of trials you make, the more number of algorithms you try, you have a higher chance of hitting the bullseye. There is no standard thumb rule that if this is the problem, this is the solution. That never works in the AI world. Finally, once you have figured out the solution, how do you develop it, right? Like I said, there are open source platforms. Do you build something on your own? Do you buy something? Do you go with a hybrid approach? What should be the technology stack? All of those questions become the next guiding principle. How do you approach and design that solution on paper? Once the solution is built, we spoke about testing and validation, Uber's example. How do you set the right guardrails to ensure that your solution, your model is working for all use cases? Because the cost of that one mistake could be probably millions of dollars or something hazardous to human life as well. Finally, it has to scale. You build a great solution that works for probably one country, one product, one business use case, but it may definitely not lead to the impact that you are looking for. So how do you really build a scalable solution is a different question altogether. How can you run it on thousands of data points, millions of data points at the same efficiency levels as well? And finally comes the monitoring and anomaly detection piece, where you have to continuously monitor. And in no way these are linear stages, right? It could go in parallel, in cyclic form. You could jump from one to the other. It's a continuously learning process. That's why you have the word machine learning, deep learning, reinforcement learning. There has to be a learning somewhere. Right, so in the interest of time, what we wanted to do was take up a couple of use cases. This is where we are building something called as a career guidance engine. The core principle remains same for retail and banking as well, where first we understand who the user is or the persona of the user. Right? Because this is career management, I'm talking about skills, career, desired role, etc. In a retail scenario, this would be their purchase patterns, the offers that they have used, the campaigns that they have responded to, and so on. Probably in a banking world, this would be the credit score, the credit history, the loan amount, income, and so on and so forth. The objective is to really understand the persona of the user. Once you do that, then comes the second piece, which is the journey analysis piece. Similar customers would have taken a good path with you. There are similar customers who would have taken a not so good path with you as well. How do you differentiate between the two? How do you analyze what's that next best step to offer to the customer so that you take maximum number of people on that ideal path as well? And then finally comes the whole recommendation piece. In this case, we are trying to recommend a good job or a good career course or a learning path for the customer. But again, like I said, in the retail case, it could be what's the next best product to cross-sell to a customer. In the banking scenario, it could be should we offer a loan to this customer, or is he at high risk from a fraudulent perspective as well. It could be any of those use cases, but the objective is to understand who the user is, what's the optimal path, and what's the recommendation we have. The second use case, I will probably quickly jump to the second one, even more interesting one. I'm pretty sure all of you would have had a time when you ended up calling a customer support, got frustrated because the agent started asking random questions. You had to give him the same information 4 or 5 different times. The issue is still not resolved, right? Now you would be wondering, why do I show a Google map in that context, right? So the way Google Maps works, obviously all of us know, is there is a source, there's a destination, and the objective is to find the shortest path to the destination, obviously. Now take that to the customer support scenario. There is a problem. this is a laptop example. So the laptop does not have a power. There is some way to get to the power, multiple routes that the agent can take to get there. Right? He can ask the customer to restart the laptop, change his adapter, and whatnot. How do we help the customer support agent find the shortest path? Right? So the point here being, you would never imagine that the same algorithm or the same concept that Google Maps uses could be used to solve a customer support issue as well. Right? But that requires, again, the whole 7 guiding principles that I talked about. How do you identify the right data streams? This is everything from the logs getting generated on your laptop to the last call that the customer made, to the kind of warranty that the customer has, the product information about failures of motherboards, hard drives, and so on as well. Right? All of that intelligence goes in. Then we need to do 3 things. As soon as the customer calls in, identify what the issue is. Number 2, identify similar issues where they're solved in the past. Number 3, given that, what's the next best step that we recommend to the customer, right? So now, what happens now, once this solution is built, is as soon as the customer calls in, the voice gets translated to text, transcript gets generated. Based on certain keywords, symptoms, the agent immediately identifies what the problem is. The algorithm or the AI agent at the back end gives him that intelligence, that 90% probability that this is an issue with an adapter probably. Once we do that, we do something called as network resolution modeling. This is, again, predicting if I take a step, what's the likelihood that the customer will call back? What's the likelihood that the issue will be solved? What's the likelihood that the customer will be happy at the end of the call? Right? So predictive probabilities of all of that is what we do. And based on that, we recommend what's the next best step to take as well. Right? So as you are now calling this particular laptop company that we work with, at the back end, though the agent is speaking to you, at the back end, there's an AI intelligence agent guiding him to ask the right questions, to suggest the right next steps to you as well. So those are just few examples of some of the other analytics that we are able to do as well. Obviously, you can deep dive into what kind of customer issues do they call very frequently for. You can obviously audit a lot of things, anything from did the agent ask the customer the right questions, did he empathize with the customer or not, did he greet the customer at the start of the call, did he do a recording disclosure or not. All of those could be audited. And then finally, we are now able to, I guess sentiment analysis is pretty old now. We are trying to get to emotion detection as well now, right? So did the customer sound angry, sad, happy, and so on. Very quickly, one more example for, would you be able to play the video on the slide? This has a video. Yeah, that should be it, yeah. Yeah, so this is more on computer vision, image analytics, etc. Imagine a typical shelf in a retail store. Someone comes, picks up a product. Historically, you would only know what the end product that was purchased was, right? But now, with all that tracking, we are now able to also identify whether the customer compared two products or not. Did he turn back and look at the price and keep something back or not, right? And all of that information is fed to the backend demand management, inventory forecasting modules that you would have. Similarly, you can now track anything that's happening in your store. Big use case for assortment optimization. How do you package your products together? How do you keep them together? What are the hottest parts within your store? All of that is completely trackable, right? Few use cases that I mentioned, but there's that entire laundry list of the things that you can do if you can decode images, videos, live streams using computer vision as well. So these were just, in the interest of time, like I told, almost out of time, 30 seconds. These were probably 2 or 3 of the use cases of the hundreds that we have solved for our global client base. We work with 200 clients globally, most of them Fortune 500, across industries from retail, banking, edtech, manufacturing, finance, and whatnot. And what has helped us grow to the size and scale that we are at today, being one of the leading data science service providers across the globe. Are we a body shop? No. Are we a product company? No. Are we a pure play consulting firm? No. We wish to think of ourselves as problem solvers who use data science and AI just as a means to achieve business transformations, right? That's our focus. Do come to our booth. We'll be happy to help you with that AI transformation journey for your transformation as well. Happy to take any questions. Okay, I guess no questions. Thank you.